To solve for x, the process are very similar. The goal is to get x all by itself on one side, and in the process, we want to balance the left-hand side and the right-hand side. And the strategy is always to undo something. Okay, so we call those inverse operations. So for example, adding and subtracting, they undo each other, and they would result in a 0 when they undo each other. And make sure that it's the same number. So the same number. Okay. Another case is if you multiply and divide the same number, then they would undo each other and they would result in 1. Okay. So now let's look at an example E here. 6x minus 2 equals 28. So the goal is to get x by itself, right? But you can see that there are two things that's on the same side as x right now. So we don't want that. We want to undo these things to get just x. But because there are two numbers, we need to think about which one we do first. Okay? So the order of operations is always doing multiply and divide first, and then do adding and subtracting, right? So that's the normal order of operation, okay? But to undo, so we want to make a side note here. To undo, you would do adding and subtracting first. Then you would do multiplying and divide. Because to undo something is the reverse of a normal order, right? So that's our strategy. Okay. So that means in this example, because we're undoing things, we want to undo this subtraction first. Okay, so what would undo a subtraction? Addition, meaning adding, right? So we'll add the same number on both sides. Okay, so when the subtraction and addition undo each other, they would result in 0. So they just go away. So what's left on the left-hand side is just 6x. And on the right-hand side, we have 28 plus 2, which is 30. Okay. Now, the next step is we still have to undo the 6. So 6 is a multiplier, so that means 6 times x. So what would undo times? What would undo multiplying? Dividing. So we'll divide 6 on both sides. So when you multiply and divide when they undo each other, they will result in 1. Okay? And on the right-hand side, 30 divided by 6 is 5. Okay? So the answer is 5 because 1x is the same as x. So now that looked like quite a process, so we better check it. So we're going to replace the x with the solution we got, which is 5. So I plug in 5 in here, so that means we'll have 6 times 5 and then minus 2, and I want to check if it would balance the right hand side, which is 28. So the left hand side is 5 times 6 is 30, 30 minus 2, and that would be 28. Does that balance 28 on the right hand side? Absolutely, because they're the same number. So that tells me my answer is correct. Okay, let's look at another example. X divided by 3 plus 11 equals 20. So same goal here. We want x by itself on one side. In the process, we want to balance the left-hand side and the right-hand side. And the strategy is to undo things. So we have the dividing 3 and the adding 11 to undo. Which one should we do first? Well, because we're undoing, we're going against nature, we're going to do plus and minus first. So we will undo the plus 11, which is minus 11. And we would do that on both sides to balance the equation. Okay, so when you add and subtract the same number, they would be 0, and what's left is x minus 3. And on the right hand side, 20 minus 11 is 9. Okay, so now you still have dividing by 3 to undo. So what would undo dividing? That would be multiplying. So we'll do multiplying the same number on both sides. So when you multiply and divide and they undo each other, you would result in x. I'm sorry, just 1. So 1x. And then on the right hand side, 9 times 3 is 27. So your answer is 27 because 1x and x are the same thing. Once again, better check it. We will plug in this number in the original equation. So we'll replace the x with 27, which is what we found. And it was divided by 3 and then add 11. Does that come out to be the same number on the right-hand side? So 27 divided by 3 is 9. 9 plus 11 is going to be 20. It's exactly the same number on the right-hand side. So that tells us 27 is the correct answer.